Something that we will commonly need to do when dealing with angles is determine the reference angle for that angle. A reference angle, by definition, is an acute angle, so it has to be less than 90 degrees. It is formed between the terminal arm and the x-axis. Now, this could mean we continue to rotate counterclockwise. It could mean we rotate back clockwise, but I've shown examples here of what each reference angle would look like in each quadrant. So in quadrant 1, we have our angle theta in red. The reference angle would actually go back and overlap that angle. In quadrant 2, we wouldn't go back to the initial side because that angle would no longer be acute. We would go to the negative side of the x-axis. Quadrant 3, we'd go back over part of the original angle. And quadrant 4, we'd go back to the x-axis. Key things to note with reference angles: they must always be acute, they must always be less than 90 degrees, and they must always join to the x-axis. So, to determine the reference angle for a given angle, first we need to draw the angle itself in standard position, 130 degrees, initial side. Terminal side would be into quadrant 2, 40 degrees in fact. The reference angle must always be drawn from the terminal side to the x-axis, so we must draw it here. And at this point, it's a little bit of common sense to figure out the actual angle. We know that this angle here would be 180 degrees. So 180 minus 130 would tell us that the reference angle would be 50 degrees. Likewise with a 300-degree angle, initial side on the positive x-axis. Going clockwise 300 degrees would take us into quadrant 3, 30 degrees in there. This is our angle. The reference angle in this case would have to be drawn back to the x-axis here. And what we know is that if we take the angle plus the reference angle, that gives us one full rotation, that gives us 360 degrees. So 360 minus 300 gives us a reference angle of 60 degrees here.